Hello! In this video, we'll look at how to do function calls in assembly language. So a function call is something like this, where say we have a main function that calls another function, in this case called sum. The caller is the one that's doing the calling, so in this case main is the caller, and the callee is the function that's called, which in this case is sum. So this is kind of silly. We could write a function that adds two numbers together and returns their result. So y is the sum of 42 and 7. When we call sum, a is 42, b is 7. We compute a plus b is 49 and return that as the value, which goes into y in main. Let's start with a simple function call, a very simple one. Say in main, we just call a function called simple that takes no inputs and returns no outputs. And then we do something else like a equals b plus c. Let's say the main function is right here. To call simple, we do a jump and link to simple. That transfers the program. Let's look at the rest of the code and then see how it works. Then when we come back, we do an add. S0 gets S1 plus, let's make that an S2. And then we keep going in main. The simple function does nothing at all, it just needs to return. And it does that with a jump register to return address. So let's look at how these jumps work. Jump and link to simple does two things. One is the link. It stores the return address, which is the current program counter plus 4, into the RA register. So right now the program is at address 300 in memory. The next instruction that we want to come back to is 304. So 300 is what we call the program counter, saying where we are in memory. And so we store 304 in the RA register. Then we jump to the label simple and we change the program counter over to be 51C, the address of the simple function. The simple function doesn't do anything, it just returns. To do that, we do this jump register instruction to RA. So RA contained the value 304. A jump register to RA will jump back to location 304, which returns to the next function after the simple function call. And you'll note simple is declared as void, meaning that it doesn't return any values. So let's generalize this. If we had arguments, the calling function needs to put the arguments somewhere that the callee will find them, and then jump to the callee with that jump and link command to go to the callee and also save where to come back to. The callee now needs to do the function. It needs to return to the caller, return the result to the caller, and go back to the point of the call. And it mustn't overwrite any registers or memory that the caller was expecting to still have. So it can't trash the caller's variables, for example. So to do a function call, we use that jump and link, and then name of the function. To return, we use the jump register RA. We pass arguments in registers A0 through A7 for up to 8 arguments, and we take the return result in A0. So these are conventions for RISC-V. There's no magic reason that all functions have to go this way, but if everybody agrees to have functions look for their arguments in these places and return the value in A0, then two different people could write two different functions without having to consult each other about which registers will be used. So here's a slightly more interesting function. Let's say that we wanted main to do a difference of sums. We'll have some integer y, and y is going to be the difference of sums of 2, 3, 4, and 5. Then the difference of sums function will take 4 arguments, f, g, h, and I, and it will compute f plus g minus h plus I. It computes that, puts it in result, and then returns the result. So when we come back to main, the answer is in y. Here is a assembly language code for doing that. So let's say in main, S7 contains y. And first we need to put the arguments in. We're calling diff of sums of 2, 3, 4, and 5. So we need to put 2 in A0, 3 in A1, 4 in A2, and 5 in A3. Then we can do a jump and link to diff of sums, and our result comes back in A0. We wanted to put it into S7, into y, so we can use the add S7 gets A0 plus 0 to move the return value into y. Then we could keep going. Let's look at the diff of sums function. Suppose for that function we wanted to keep the result, use S3 to hold our result. Then we could first add f plus g that were in A0 and A1, put that in T0. Next we could add A2 and A3, put that in T1. Next we could subtract T0 minus T1, put that in S3. So that's our result equals the f plus g minus h plus I. Then we want to return this result, so we need to copy the result from S3 into A0. We can do that with an add A0 gets S3 plus 0. And finally we return with that jump register to RA. Now you notice it was a little bit wasteful to put our answer in S3 and then immediately have to copy it to A0. And if we were writing an optimizing compiler, or if we cared about optimizing this by hand, we could have just had the subtract put the answer straight in A0. But for now, let's do it in a straightforward way and not worry about those optimizations. All right, so let's look a little more closely. The diff of sums function overwrote 3 variables, T0, T1, and S3. And the main function might have been expecting to use some of those registers. So diff of sums can use something called a stack to temporarily store registers so we don't overwrite things. And we'll look at that in more detail in another few videos.